Now that we know all of our great properties, we know how to expand, we're going to practice writing a logarithmic expression in expanded form. So these are going to be a little bit tougher than the last questions we did when we only had one property to look at. We're going to look at all the properties and expand. So let's look at this first one together. I'm looking at log base 4, and I've got products and I have quotient. So if I'm writing it using the quotient rule, it would be log base 4 of 5x minus log base 4 of yz. However, I've got two things here and two things here, so essentially I need to break each of those up. Now you can do this all in one step. I'm doing it step by step just in case we're not tracking. So we're going to go step by step with me. This one would be log base 4 of 5 plus log base 4 of x. And now I've got minus, but I've got minus all of that. So it's going to be minus log base 4 of y. And normally I would put a plus here because it's a product, but this is minus this whole thing. So it's actually minus log base 4 of y plus log base 4 of z, but I have to distribute that negative. So essentially I'm going to write the negative in both places because they're both part of the denominator. So again, if you go straight to this, that's fantastic. That means you're really understanding these properties. If you need to write that step in between, do not feel bad about it because that's how you get to the final answer, and that's just fine. So on my second one, I'm not going to do the in-between step. I'm just going to go straight to the answer. So in my numerator, I have log base 2 of 4, and I'm going to use a plus because it's still in my numerator, log base 2 of a. In my denominator, I have log base 2 of 8, so minus log base 2 of 8, and then minus, again because it's still in the denominator, log base 2 of b. And you should now get into the habit of replacing things that you can. Log base 2 of 4 says 2 to what power is 4? This is a 2. Log base 2 of a, I cannot evaluate unless I know what a is. But log base 2 of 8 means 2 to the third power is 8. And then of course log base 2 of b I can't evaluate unless I know b. So my final simplified answer would be combining 2 and minus 3 to get negative 1 plus log base 2 of a plus log base 2 of b. We don't want to forget about that natural log guy. It's the same exact properties that we used before, but just remember sometimes we use natural log instead, so we just stick with it. So here, these are obviously being multiplied, so I would say natural log of a squared plus natural log of b. And then because I have an exponent, I'm not done yet. I would have to then use that power property that says this is 2 times the natural log of a plus the natural log of b. Now I'm done. Second one, again, before I try to do an expanded form, I want to rewrite my numerator so that it says x to the 2/3. 2 is the exponent, 3 is the index, over y minus z. So this is what I'm going to expand. In my numerator, whoops, I don't need that. In my numerator, I've got natural log of x to the 2/3, which I'll continue to reduce in a minute. Then in my denominator, I have natural log of y minus z. So my first term, because I have an exponent, again I use the power rule that says 2/3 natural log of x, but that second one, not much I can do about it. I'm going to leave it just like that. This last guy is for you to try all by yourself, so press pause, try the question, then press play to see how you did. So again, the first one, I've got two values on the top, so that means a plus in between. So log, this is base 10, but you don't write the 10, log of a to the 5th plus log of b squared. My denominator, which means I'm subtracting, log of c to the 3rd. As we can see, we have a plethora of power rule here because we've got all sorts of exponents. So this is 5 log A plus 2 log B minus 3 log C. Good work if you got that one right.